Welcome to Spring LIB.
Okay, so in this problem we have a wheel, then there's a string attached through the wheel. Also there are two blocks, block A and block B, that are attached at the end of the strings. And from the given values we can see that block A is heavier than block B. So for our convenience, let's choose downward y direction as positive for block A, and for block B, upward direction as positive. And for the wheel, let's say the clockwise direction is positive. Now let's see what we need to find. So we have to find the linear accelerations for A and B, and also angular acceleration for C. So in other words, linear acceleration will be A, and the angular acceleration will be alpha, and the tensions in the string. So for A, it will be TA, and for B, it will be TB. So the way we will do this problem is, we see that block A and block B has only translational motion or linear motion. They can just move linearly, but the wheel only has rotational motion. It doesn't go anywhere, it just rotates. So that's why we'll be applying the force equations on each parts. So for part A and part B, we'll just apply the linear force equation, which is F equals ma, where A is the acceleration. And for the wheel, we'll be applying the torque equation, which is just the rotational equivalent of force. And that's I times alpha, where alpha is the angular acceleration, I is the moment of inertia. So let's uh, do one by one. Let's start with block A, which is the heavier block. So for this, we'll be having two forces acting downwards. One is MAG due to block A, and here MBG due to block B. So if we take only this part, we see that the resultant force is the difference between the tension force and MAG. And since the box is moving downwards, that means MAG minus T should be equal to MA times A. And the reason being tension negative here, let's call it actually TA. The reason being this is negative is we considered downward direction as positive here, so that's why TA is uh, negative, and mg and this direction are on the same direction, so that's why that's positive. Now, so this is for A. Now for B, we'll be having TB minus MBG, which is equal to MBA. And as we see here, we see that tension and the positive direction are on the same side. That's why TB is positive, but this is negative because this is in the opposite direction. Okay, so that concludes the linear part. Now for the wheel, so let's call it wheel. For the wheel, um, we'll be having the change in tension force, TA minus TB, times R. So this is the linear force times R, which is basically torque. That's equal to I times alpha, where I is again the moment of inertia. And since this is a problem of rolling without slipping, so we can consider alpha equals to um, A over R, where R is the radius of the wheel. So we can substitute that over here, and if we do so, we have TA minus TB times R equals to I times A over R. Right. From there, we can do a little modification. We can take this r over here, and then we'll get a over r squared. Okay, so we have 3 equations now and 3 unknowns, so we can figure out t. So the 3 equations are this one from the wheel, from box B, and from box A. Now there are 3 unknowns, TA, TB, and A, and there are 3 equations, so it's solvable. Now if we combine these 3 equations, we'll get MA minus MB times G, which is equal to MA plus MB plus I over R squared times A. And from here, if we solve for A, we'll get MA minus MB over MA plus MB plus I over R squared times G. Now we are given MA as 2 kg, MB as 4 kg, I as 0.22 kg meter squared, and R as 0.12 meter. So if we put all these numbers here, of course G is 9.8 meter per second squared. So if we use all the numbers over here, we see that A, or the linear acceleration, will be 0.921 meter per second squared. Right, so this part is done. Now what about alpha? So since we mentioned here that this is a problem of rolling without slipping, so alpha will be A over R. So alpha is A divided by R, which is 0.921 meter per second squared divided by 0.12 meter, which is 7.68 radians per second squared. Now alpha is done as well. So what about TA and TB? So for TA, we can use this piece of equation, and for TB, we can use this to solve TB. So TA will be MA times G minus A. And again, if we use all the given numbers, we see that this value is 35.5 newtons, and TB will be MB times G plus A, which is 21.4 newtons. So that's how we figured out TA, TB, alpha, and A. Thank you.